The room is full. Please, no new people in the room. This room is now full. Sorry, there is no more room in this full. We're actually over capacity. We're not actually allowed to sit in the stairs or stand on the wall by the rules of the university. Otherwise, okay. Thank you. I suspect someone is sitting there. No. Okay, good. Sorry, we're full. Yeah, apparently there's a problem with the mic. Yes. The volume. So what? F1? Sorry, yes, so we're just going to be testing the microphone a little bit more here. Testing the microphone. Stuff happening with the microphone, seeing if we can hear this. It's closer up. Okay. Okay, so the next presentation will be from Joachim, and it's going to be about XMPP, which is a system for presence and messaging, which I'm sure Joachim will explain, in the context of IoT. Does that mean putting XML on little things? Oh, terrible. Okay. Sorry. Well, I don't know. I hope you don't put like a whole validating engines and so on your Arduinos. It's going to be tragic. So, yes. So we're just setting this up. Can we have some applause and see if it generates some noise? There's room. Yes, excellent. Okay. I can't hear you. I can't hear you. This is tragic. Okay, good.
That's a very small screen. I'll speak very close to the microphone. And I have a computer that's very slow. No problem. Well, if I guess using Macs and screens isn't very good. Just went away. But it's very small. So where is my Firefox? There. And I have 10. Oh, I need to do this. I hate Mac for this. The only way to make the window lesser is from the right corner. And that's very far away now. Again. See what the Mac is doing now. Okay. That should get us almost going. Yeah, wonderful. And it starts in the middle. So I'm Joachim Lindborg from Sweden. I work at a little company called Sustainable Innovation. We work with energy efficiency services, energy efficiency at total. We're working with very lot of companies across academia to energy providers and utilities and so on. And as you know, there's a huge device explosion. You probably have a lot of these at home. Often you build them yourself. And what do you do there with them? Well, you would like to connect them to the clouds. That's what you all do. First thing you do, you get it on the net and then you throw your data to a database somewhere. Either you do it by yourself, or you buy a thing with a service in it. So how many have a thing with a service to it? Yeah. So it gets on the net, Wi-Fi, whatever, and it throws the data to a server somewhere, creating a very nice business silo. And then you get a nice open API. Hopefully it's somewhat the same. And hopefully they do off, so you can combine them and learn everybody of them. So in the end, in your home, you would have a heat pump with an app, your scale with an app, refrigerator with an app, and an alarm with an app. Impossible to interoperate between them. So as a customer, you're sitting there with all these companies, trying to get a smart home, if you haven't created it yourself. So getting a temperature from an alarm company's sensors to your heat system, it's a very long way. There's a lot of interoperability issues in between, a lot of APIs to travel, and a lot of projects to do with big companies. So there is a solution that we tried in the project. It's called chat. How many has a chat client? Ah, that's pretty good. So you get to make friends. And when you have a friendship relation, you can talk to them, preferably on a language both of you understand. English, German, or whatever. That's part of the chat message transport. And in the company, the project we're doing with energy efficiency services, we now have glued XMPP to the devices from all these companies. So my little friend smoke detector can be friend to my heat pump, regardless of the domain it's originated in. So the smoke detector from Very Shore could talk to my heat pump.se. No problem, it's a chat. But they need to have a language, of course. So all these generic servers that's available on the XMPP network, you can implement in any language. You can implement any server in any language. You could choose ready-made servers. You can have your server at home, if you like your own domain. Or you can let the companies actually keep their silo, but open up a device, a view, over the chat language. So if they have an internal API, you can move that to be an XMPP view and be federated, which we just heard is a very good thing. You would have different identities, different identity solutions, and you can hide every nice little protocol behind it. So what we've done with the alarm companies, they of course doesn't open anything locally. It's very secure, you know. So we only get the API on the server side. But we have then glued XMPP on it, so every alarm instance would be a JID on the XMPP network. So I can talk to my alarm, asking for smoke detector number 1's temperature, and move that over to the heating company. So that's now done in Sweden in this project we do. And to get the language right, XMPP has a very nice view of extensions. Anybody seen those extensions? And yes, they are XML. So when you do an extension to the network, you don't really demand any changes in servers for most of them. If you do publish subscribe, you would need an instance working in the server as well. But most of the things are doing client to client. For example, an extension of presence or humor or whatever you need to have. So we've done extensions now to send sensor data, which create an XML language very defined of how to move the data between two clients on any domain. That's quite useful. So go away from the actual chat as a pure tunnel of any data. We go to the XML transport with a defined namespace to read and write data. So you know when you get that XML package, this is a temperature, and it's in Celsius. I could convert it to Fahrenheit if I want to, and I will be interoperable between different systems, between different domains, any local protocol. And yes, this is just another way of doing standardization, of course. But if you wait for ISO to do the ultimate Internet of Things transport protocol, we need to wait for a while. And the good thing with XMPP is that it's one authority called the XSF Foundation that does the standardization in the end. Anybody can contribute, and these extensions are now in experimental. So it's just to battle them, make them fail, so we can change them, right? It's a very new initiative. We've just done it for a year now. So we're on talking, trying. We've done implementations in Python for Raspberry. And yes, no, we haven't been making it for Arduinos. We do demand TLS. No chat client should ever do anything else. So this is not an aim to make a wall switch turn on your lamp. It's not an aim for this. This is when you, away from home, need to turn your state of your house to another state, or look at something at home, or communicate between company domains. So, sorry for not breathing. I go just briefly through the steps. We have the 323, which is a sensor data read. So that's the way you go to either between two devices or from a statistical engine pull data towards a device. The transport looks a bit complicated, but it's because you never know what's behind that chat service. It could be an electricity grid. So if you asked, hey, give me all the values, and it would reply, accepted, and then you will have data for a month, because it will continuously provide you with messages of all the devices that's behind. So therefore the bit complicated transport. But you could simplify it. If you adjust the temperature, you get the request and you receive a response. So that's for reading. And of course, almost the same thing is for writing. That's the example of the actual XML. You do the get with wanting to read momentary values, and you would get a request accepted, and then the message is pouring over with values. And those could be either as each messages if they are contained a separate device, or they could be a number of values as part of that message if itself has a lot of values. And another thing for doing this is that one device could take quite a long time to calculate the value you're asking for. It could need to do a physical thing with a lot of muck around devices or IOs, and then it needs to have an analog IO conversion and calculate. And perhaps it does have a very small footprint. So when doing control, and the choose for doing another namespace is that you can, in XMPP, do a discovery. So you can talk to any chat client and discover what it's capable of. So if you do that for a chat client, it would respond, I can do chat. And these devices can then respond, I can do read. And I can also do write. So you could interact with it. And an example of write is fairly the same. I do a set, and I get a response. It worked. And now you can do that cross over the world to any device, anywhere that you're a friend of. But if you're a friend with my alarm, I would rather not let you send a control of the status of my alarm setting is to off. Perhaps, if you're not my very, very best friend. So therefore, we need a notion of provisioning and security for authorization. We have the authentication that's done in the network as a part of XMPP already today. TLS, passwords, you can do certificates or whatever towards your server. So how do we let my alarm not respond on the status to a friend? Because I need the friend relation sorry, to be used for the first step. So then we have introduced a best friend, which is another client on the network. So if you're a device, the first friend you get would probably be the get best friend. And that could be preset from the provider, or you start it in a push on a button and it would be an alarm mode to actually accept a friend request. That could be you on your iPhone, or it could be a server somewhere having a bot. So as soon as this thing gets another friend request, what would it do? Well, it asks the parent, my best friend, am I allowed to talk to this guy from this interesting domain? No, definitely not. So that's the first step of making authorization towards the nodes using the friendship relation. The next thing would be, okay, I'm friend with this Paul, and he wants to read the status of the alarm. Is that okay? And the best friend can then respond yes or no, and I can cache it if I want to. I can reread the cache. We have double communication, so the server, as soon as I get a presence on the network, it can push me. Well, we have changes in the relationships of your friends. So I can push down new settings for that little node. So that's the idea for provisioning. There are also parts of tokens and so on. You have logged on, you use the token, and that's why it could be transported through the network. So that's the main things you would like to use doing a secure Internet of Things, interoperable transport layer for any device in more or less any domain. If you're doing respiratory control, you need to be taken care of course. If you have some very nice hospital machinery on the other end. And it's working. We've run through several servers. We have Python implementation, a Java implementation. We have a very nice in the XMPP real-time launch, where we can even demo communication. And perhaps we will soon have a little demo as well. Yep. Yeah, but we don't do it yet. I have a few slides left. Sorry. There's another thing. All these devices. XMPP is, of course, not a protocol to use communication in between those devices at home, as we said. They could be Zigbee, Z-Wave, 6LoWPAN, of course, or whatever. But my history of going in industry and everything is that regardless of the protocol you find, if you do a little Google search, you will find an IP gateway somewhere. And several. If you're a Metasys industrial protocol, there are tons of IP gateways. At that level, it's interesting to go for the XMPP transport. Either it can do it by itself, or it has some kind of view. For example, the Philips Hue lamps have a RESTful API actually on the gateway. Quite pretty to do an XMPP transport from that upwards. And that's called a concentrator. So I can concentrate a network behind a gateway. And with the extension concentrator, I could interact with the network. So I could ask, well, do you have several nodes? How does the tree look like? Could I interact with each other, or do you just provide every field of the whole network as just a list of attributes? So that's more or less the full knowledge that we have today. XMPP does have publish subscribe. It do have multi-user rooms where you can be anonymous. So, for example, devices going into multi-user room called your smart city anonymously could share data without revealing any of your GIDs. So the smart city could use your power level or bumps in roads or whatever you find. You just pour it into that room. Very interesting. So the main idea, you find more on xmpp.org and my project site. So the main idea is to go beyond those silos. Open them, get into them, get your data back. Because the statistical engine can now be any client on the network. It could be your phone, or your computer at home, or your preferred statistical provider. So let's see if we could find an interesting demo. Since my broke when I was sitting there.
So in the real-time lounge in the K building, we have a few U lamps, Philips U lamps, hanging at the ceiling, and they're controlled by a U bridge. Joachim created an adapter from XMPP to the U bridge. We haven't gotten to the point where we implemented all this protocol, but we have at least something that is now controlling the lamps.
Not sure if you can see it, but it looks like this. I'm sorry. At the top you can see 4 of those lights. They have slightly different colors, and this program is changing them. I might be able to show you the original U application that is connected to the portal that occasionally pulls the status of the lamps, so that you guys can see that it's actually changing.
So I also have a friend with my. Oh, sorry. I also have a friend with those lights in the phone. So we have. It's a lot of blinking because there are a lot of friends to those lamps now. But it's very fun when you sort of mimic the world down to the devices. 3 minutes, yeah. And there will be a session at afternoon where we can try it out as well, if you would like to. And please go and get the code. Num 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 num. Demos are fun. So now we're going over the chat transport layer. We just having a language saying time equals, hue equals, brightness equals, and set equals. So that's more or less us sitting and chatting to the device.
I'm not sure if you can see this at all, but this is the original app. It has 4 markers for each of the lamps, one, and a color view. And the app by default pulls every minute or so the actual status. So if you see these markers move, then the actual color back in the K building is what it was right at that moment.
So please visit the lounge. So please visit the XMPP lounge, and you will see them really live, blinking. Any questions?
Yes, you can. Yes, you can, if you want. They are called after a famous band you might know, the Beatles. So each of the lamps is, as you can see, George, John, Paul, and Ringo. And if you send them messages like this, U equals and then something between 0 and 64K. The brightness goes from 0 to 54, and the same for the saturation. Then you will be controlling those lights. So come up to the real-time lounge, hang out on our very nice beanbags, and just play with the lights there.
Thank you very much. Thanks, Joachim. We'll have a 5-minute break, and then we'll have our next talker.